All right, welcome back. We're going to go ahead and take a look at the mass fractions now of the microconstituents in the eutectic system. So just to remind you, what we're looking at here is we're going to try and calculate out how much of this alloy is primary alpha. So we want to know what the overall weight fraction, mass fraction is of these spherical regions. And we want to know what the overall fraction is of the layered structures, the dark and the light, and as a whole, the whole eutectic structure itself as well. All right, so if we go back to the lead tin diagram, there's basically two tie lines that we're going to need. So I'm going to go ahead and draw my tie line on here now. I've got one tie line that I just put up there in green. Let me see if I can get a good contrast color. Let's say red. And then I'm going to have another tie line that is just below the 183 mark. So I'm trying to put one just above. So my bottom tie line I just drew represents alpha beta. So let me go ahead and pull that one out. Right? So we said this is alpha, and this is beta for that one. And overall, I'm at 40. Now my alpha here at this end is labeled at 18.3 on the diagram, and beta is labeled as 97.8. Okay, we may have to go back a couple lectures to this diagram, right? We've got 18.3 and 97.8 labeled for us. All right, so we've got those labeled. And then my upper tie line, let's draw that one. And this is my 40 location. Maybe I could have done a little better with where I put that. Let's try that again. That looks like it's more like 50-50. So 40. Again, this end of the tie line is 18.3. Remember, this is alpha. Should have labeled these first. And this is liquid. And then the liquid there is at the eutectic composition is where it intersects. That's 61.9. Okay, so I've got two tie lines and I've got them labeled. Okay, and obviously this red one's a lot longer relative to the green, but we've got the numbers that are what we're going to rely on. So I pull those two out and I want to go ahead and label what they tell me. So remember, what we're interested in is the fractional amount of all of microconstituents. So on this upper tie line, we said we had alpha on the left side. So that means my right side, by the inverse lever rule, is the fractional amount of alpha. And in particular, we said since we formed this alpha first in that alpha plus liquid region, then this is primary alpha. So I'm going to go ahead and label my diagram that way. So that tells me how much primary alpha I form. And then since the liquid's on the right side, this left side then is my fraction of liquid. All right, so all I have to do is put in numbers and I can get those fractional amounts out. And then on my bottom tie line, the alpha, right, is on the left. So the right side is my fractional amount of alpha. And then again, beta is on the right. So then my left piece is my fractional amount of beta. So now I've got everything labeled, and that really helps because then I don't have to keep all of that in my head. Everything's down on paper and I just have to follow along with what I'm doing. Now, another important point is that tie lines, whatever region you're in, that tie line tells you the total alpha and total beta, for example. So it doesn't care whether alpha is in a layered structure or whether alpha was formed in the primary case. It's essentially, this tie line is really just a mass balance. It's just a handy way of doing a mass balance. And so total is all it cares about. So what I can do is remind myself on this bottom tie line in particular that what I'm looking here at is total alpha, total beta. So what I mean by that then is that my total alpha is going to equal my primary alpha plus my eutectic alpha. Right? So I can separate it out that way. So now I have a way of getting total alpha. I have a way of getting alpha primary from my upper tie line, the green one. And therefore, if I subtract those, I will calculate then eutectic alpha, which is one of the answers I want to get. It's my eutectic alpha. All right, let's see, what else do we know? Same equation holds for beta, right? So total beta would equal primary beta plus eutectic beta. All right. But since I'm on the left side of the diagram here, we only go through the alpha plus liquid region, so I don't have any beta that's formed in that region, only alpha. So primary beta is 0. And so my total beta that I calculate with the bottom tie line is just equal to my eutectic beta. And you can see that in the picture, I hope, as well. So these two equations always hold. So you can use them to reason out what happens when you're over on the right side of the diagram. Again, we've used nothing but the lever rule. We haven't tried to plug in to a whole bunch of equations that are listed in your text. I think things will get super confusing if you do that, especially once you move over to this side of the diagram where you've got primary beta and no longer have any alpha. And the equations actually switch sides. So, all right, but that is all my information all there. Let's see, what else can I pull out of this? The fractional amount that is liquid. Let's think about that one for a second. Because the fractional amount that is liquid, we said that is what becomes the layered or eutectic structure. So that means my fractional amount of liquid I get from that upper tie line would be the same as asking for the total eutectic structure fraction, right? The total eutectic structure meaning the alpha eutectic plus beta eutectic. And so I have a way of knowing what those two equal just based on the liquid piece. So you have a lot of equations to choose from. And again, they all come from sort of looking at this picture in your mind and drawing out these two tie lines. All right, so the problem is really done. At this point, all you have to do is plug in numbers. So see, I won't plug in everything. Let's just pick a few. Let's say that we wanted to know the eutectic beta. All right, well, eutectic beta, we said, pick a new color. Eutectic beta is down here, right? We said that's going to be the same as total beta. So I need this fractional piece right here. Everything's nice and labeled for me. So that fractional piece then is just 40 minus 18.3. And that's over the total length of the tie line, which is 97.8 minus 18.3. Okay, so that would be my eutectic beta. We can just plug in the numbers. Let's say that we wanted to know what is the amount, what is the amount of the primary alpha. So let's see, primary alpha, right? We said that's the upper tie line. Here it is labeled for me. So let's go ahead and just plug in the numbers. So the length there on that right side is 61.9 minus 40. The total tie line length is 61.9 minus 18.3. So I can go ahead and get that out. All right. So that's all I have to do. If it asks you for the total amount of eutectic, You can either calculate the liquid, which we said was the total, or if you already have the eutectic beta and eutectic alpha calculated in your problem, then you can just simply add those two. It's just totally up to you. If we want the alpha eutectic, for example, remember that one is given by this equation here. So what I would want then is total alpha, and I would subtract primary alpha. So I'll get the total alpha from the bottom tie line, and I would get my alpha primary, which we just did. And then I can just go ahead and subtract them, and that would be my alpha eutectic. So everything on here is what you need. Again, draw the two tie lines, pull them out, label them, and then work from there. And make sure that you're only looking at one tie line at a time. You never use numbers from one tie line and mix it with numbers from another tie line. Okay? Both the tie lines are completely separate, and you're dealing with them just one at a time. All right. So this is what we just worked on. We went through all of this. And then if you want to test yourself, good problem to look at here is over here on the side where we get primary beta instead. So let me just show you, we get a little switch here. I'm going to draw one of the tie lines for you. Okay, so let me go ahead and pull that one out. Here's my center point here at 80. This side is 61.9, that's liquid. The other side is 97.8, and that is beta. So remember that beta is on the right side. So that means this left piece is my beta. And in particular, since I'm up top here, this is primary beta. The liquid's on the left, and so the right piece then is my fraction of liquid. So I just drew that tie line for you. The reason why I wanted to do that is because we just applied the lever rule, nothing special. And it takes care of everything for us. If you go trying to use those equations, you're going to have to remember, for example, that in this case, notice the liquid's on the right side. And when you're in the other problem, right, the liquid was on the left side. Okay, it seems trivial when you draw the tie line out and just use the lever rule. It's obvious which side it has to be on. But if you use all those equations, you're gonna end up then writing an equation for every one of these cases. Okay. All right, and then you'll go ahead and draw the tie line on the bottom to handle your total alpha and total beta. All right, so I got the answers all here for you, so you can go ahead and try that problem. And that's all it can really ask you. It's either the left side or the right side. All right, good luck.